A screw, or bolt, is a type of fastener, typically made of metal, and characterized by a helical ridge, known as a male thread or just thread. A screw is an inclined plane wrapped around a nail. Some screw threads are designed to mate with a complementary thread, known as a female thread, often in the form of a nut or an object that has the internal thread formed into it. Other screw threads are designed to cut a helical groove in a softer material as the screw is inserted. The most common uses of screws are to hold objects together and to position objects. A screw will almost always have a head on one end which contains a specially formed shape that allows it to be turned, or driven, with a tool. Common tools for driving screws include screwdrivers and wrenches. The head is usually larger than the body of the screw, which keeps the screw from being driven deeper than the length of the screw and to provide a bearing surface. There are exceptions. For instance, carriage bolts have a domed head that is not designed to be driven. Set screws often have a head smaller than the outer diameter of the screw. J-bolts have a J-shaped head which is not designed to be driven, but rather is usually sunk into concrete, allowing it to be used as an anchor bolt. The distance between each thread is called the pitch. The majority of screws are tightened by clockwise rotation, which is termed a right-hand thread. A common mnemonic device for remembering this when working with screws or bolts is righty-tighty, lefty-loosey. Screws with left-hand threads are used in exceptional cases. For example, when the screw will be subject to counterclockwise torque, a left-hand threaded screw would be an appropriate choice. The left side pedal of a bicycle has a left-hand thread. More generally, screw may mean any helical device, such as a clamp, a micrometer, a ship's propeller, or an Archimedes screw water pump. Differentiation between bolt and screw. There is no universally accepted distinction between a screw and a bolt. A simple distinction that is often true, although not always, is that a bolt passes through a substrate and takes a nut on the other side, whereas a screw takes no nut because it threads directly into the substrate. Machinery's Handbook describes the distinction as follows. A bolt is an externally threaded fastener designed for insertion through holes in assembled parts, and is normally intended to be tightened or released by torquing a nut. A screw is an externally threaded fastener capable of being inserted into holes in assembled parts, of mating with a preformed internal thread or forming its own thread, and of being tightened or released by torquing the head. An externally threaded fastener which is prevented from being turned during assembly and which can be tightened or released only by torquing a nut is a bolt. An externally threaded fastener that has thread form which prohibits assembly with a nut having a straight thread of multiple pitch length is a screw. This distinction is consistent with a SME 18, 2.1 and some dictionary definitions for screw and bolt. The issue of what is a screw and what is a bolt is not completely resolved with Machinery's Handbook distinction, however, because of confounding terms, the ambiguous nature of some parts of the distinction, and usage variations. Some of these issues are discussed below. Machine screws. ASME standards specify a variety of machine screws, in diameters ranging up to 0.75 in. These fasteners are often used with nuts as well as driven into tapped holes. They might be considered a screw or a bolt based on the Machinery's Handbook distinction. In practice, they tend to be mostly available in smaller sizes, and the smaller sizes are referred to as screws or less ambiguously as machine screws, although some kinds of machine screw can be referred to as stove bolts. Hex cap screws. ASME standard B18 2.1-1996 specifies hex cap screws that range in size from 0.25-3 in diameter. These fasteners are very similar to hex bolts. They differ mostly in that they are manufactured to tighter tolerances than the corresponding bolts. Machinery's Handbook refers parenthetically to these fasteners as finished hex bolts. Reasonably, these fasteners might be referred to as bolts, but based on the U.S. government document distinguishing bolts from screws, The U.S. government might classify them as screws because of the tighter tolerance. In 1991, responding to an influx of counterfeit fasteners, Congress passed Place 101 to 592 Fastener Quality Act. This resulted in the rewriting of specifications by the ASME B-18 Committee. B-18 2.1 was rewritten, and as a result they eliminated the finished hex bolts, and renamed him the hex cap screw, a term that had existed in common usage long before, but was now also being codified as an official name for the ASME B-18 standard. Lug bolts and head bolts. These terms refer to fasteners that are designed to be threaded into a tapped hole that is in part of the assembly, and so, based on the machinery's handbook distinction, they would be screws. Here common terms are at variance with machinery's handbook distinction. Lag coach screw. Lag screws or coach screws are large wood screws. Square-headed and hex-headed lag screws are covered by ASME B-18 2.1 standards, and the head is typically an external hex. A typical lag bolt can range in diameter from 1/4 in to 1 1/4 in, and lengths from 1/4 to 6 in or longer, with the coarse threads of a wood screw or sheet metal screw thread form. The materials are usually carbon steel substrate with a coating of zinc galvanization. The zinc coating may be bright yellow or dull gray hot dip galvanized. Lag bolts are used to lag together lumber framing, to lag machinery feet to wood floors, and for other heavy carpentry applications. The adjective lag came from an early principal use of such fasteners. The fastening of lags such as barrel staves and other similar parts. These fasteners are screws, according to the machinery's handbook criteria, and the obsolescent term lag bolt has been replaced by lag screw in the handbook. However, in the minds of many tradesmen, they are bolts, simply because they are large, with hex or square heads. United States government standards. The federal government of the United States made an effort to formalize the difference between a bolt and a screw, because different tariffs apply to each. The document seems to have no significant effect on common usage and does not eliminate the ambiguous nature of the distinction between screws and bolts for some threaded fasteners. The document also reflects significant confusion of terminology usage that differs between the legal, statutory, regulatory community and the fastener industry. The legal, statutory, regulatory wording uses the terms coarse and fine to refer to the tightness of the tolerance range, referring basically to high quality or low quality, but this is a poor choice of terms, because those terms in the fastener industry have a different meaning. Historical issue. Old US and SAE standards defined cap screws as fasteners with shanks that were threaded to the head and bolts as fasteners with shanks that were partially unthreaded. The relationship of this rule to the idea that a bolt by definition takes a nut is clear. This is now an obsolete distinction. Controlled vocabulary versus natural language. The distinctions above are enforced in the controlled vocabulary of standards organizations. Nevertheless, there are sometimes differences between the controlled vocabulary and the natural language use of the words by machinists, auto mechanics and others. These differences reflect linguistic evolution shaped by the changing of technology over centuries. The words bolt and screw have both existed since before today's modern mix of fastener types existed, and the natural usage of those words has evolved retronomously in response to the technological change. Non-threaded fasteners predominated until the advent of practical, inexpensive screw cutting in the early 19th century. The basic meaning of the word screw has long involved the idea of a helical screw thread, but the Archimedes screw and the screw gimlet preceded the fastener. The word bolt is also a very old word. The connection of this sense to the sense of a door bolt or the crossbow bolt is apparent. In the 19th century, bolts fastened via screw threads were often called screw bolts in contradistinction to clench bolts. In common usage, the distinction is often that screws are smaller than bolts, and that screws are generally tapered while bolts are not. For example, cylinder head bolts are called bolts, despite the fact that by some definitions they ought to be called screws. Their size and their similarity to a bolt that would take a nut seem linguistically to overrule any other factors in this natural word choice. Proclivity. Other distinctions: bolts have been defined as headed fasteners having external threads that meet an exacting, uniform bolt thread specification such that they can accept a non-tapered nut. Screws are then defined as headed, externally threaded fasteners that do not meet the above definition of bolts. These definitions of screw and bolt eliminate the ambiguity of the machinery's handbook distinction, and it is for that reason, perhaps, that some people favor them. However, they are neither compliant with common usage of the two words nor are they compliant with formal specifications. A possible distinction is that a screw is designed to cut its own thread. It has no need for access from or exposure to the opposite side of the component being fastened to. This definition of screw is further reinforced by the consideration of the developments of fasteners such as Tek screws for roof cladding, self-drilling and self-tapping screws for various metal fastening applications, roof batten screws to reinforce the connection between the roof batten and the rafter, decking screws, etc. On the other hand, a bolt is the male part of a fastener system designed to be accepted by a pre-equipped socket of exactly the same thread design. Types of screw and bolt. Threaded fasteners either have a tapered shank or a non-tapered shank. Fasteners with tapered shanks are designed to either be driven into a substrate directly or into a pilot hole in a substrate. Mating threads are formed in the substrate as these fasteners are driven in. Fasteners with a non-tapered shank are designed to mate with a nut or to be driven into a tapped hole. Fasteners with a tapered shank. Fasteners with a non-tapered shank. Fasteners with built-in washers. A fastener with a built-in washer is called a SEM, or SEMS, short for pre-assembled. It could be fitted on either a tapered or non-tapered shank. Other threaded fasteners: superbolt, or multi-jack bolt tensioner. A superbolt, or multi-jack bolt tensioner is an alternative type of fastener that retrofits or replaces existing nuts, bolts, or studs. Because of this, the amount of torque required to achieve a given preload is reduced. Installation and removal of any size tensioner is achieved with hand tools, which can be advantageous when dealing with large diameter bolting applications. Boned screws. The field of screws and other hardware for internal fixation within the body is huge and diverse. Like prosthetics, it integrates the industrial and medico-surgical fields, causing manufacturing technologies to intersect with the art and science of medicine. Like aerospace and nuclear power, this field involves some of the highest technology for fasteners, as well as some of the highest prices, for the simple reason that performance, longevity, and quality have to be excellent in such applications. Boned screws tend to be made of stainless steel or titanium, and they often have high-end features such as conical threads, multi-start threads, cannulation, and proprietary screw drive types. List of abbreviations for types of screws. These abbreviations have jargon currency among fastener specialists. The smaller basic ones can be built up into the longer ones. For example, if you know that FH means flathead, then you may be able to pass the rest of a longer abbreviation containing FH. These abbreviations are not universally standardized across corporations. Each corporation can coin their own. The more obscure ones may not be listed here. The extra spacing between linked terms below helps the reader to see the correct parsing at a glance. Materials. Screws and bolts are usually made of steel, where great resistance to weather or corrosion is required, like in very small screws or medical implants. Materials such as stainless steel, brass, titanium, bronze, silicon bronze or monel may be used. Galvanic corrosion of dissimilar metals can be prevented by a careful choice of material. Some types of plastic, such as nylon or polytetrafluoroethylene, can be threaded and used for fastenings requiring moderate strength and great resistance to corrosion, or for the purpose of electrical insulation. Often a surface coating is used to protect the fastener from corrosion, to impart a decorative finish or otherwise alter the surface properties of the base material. Selection criteria of the screw materials include size, required strength, resistance to corrosion, joint material, cost and temperature. Bolted joints. The American Institute of Steel Construction 13th edition Steel Design Manual Section 16.1 Chapter J3 specifies the requirements for bolted structural connections. Structural bolts replaced rivets due to decreasing cost and increasing strength of structural bolts in the 20th century. Connections are formed with two types of joints: slip critical connections and bearing connections. Slip is prevented through friction of the faying surface, that is the plane of shear for the bolt and where two members make contact. Because friction is proportional to the normal force, connections must be sized with bolts numerous and large enough to provide the required load capacity. However, this greatly decreases the shear capacity of each bolt in the connection. The second type and more common connection is a bearing connection. In this type of connection, the bolts carry the load through shear and are only tightened to a snug fit. These connections require fewer bolts than slip critical connections and therefore are a less expensive alternative. Slip critical connections are more common on flange plates for beam and column splices and moment critical connections. Bearing type connections are used in lightweight structures and in member connections where slip is not important and prevention of structural failure is the design constraint. Common bearing type connections include shear tabs, beam supports, gusset plates in trusses. Mechanical classifications. The numbers stamped on the head of the bolt refer to the grade of the bolt used in certain application with the strength of a bolt. High-strength steel bolts usually have a hexagonal head with an ISO strength rating stamped on the head, and the absence of marking number indicates a lower-grade bolt with low strength. The property classes most often used are 5.8, 8.8, and 10.9. The number before the point is the ultimate tensile strength in MPa divided by 100. The number after the point is the multiplier ratio of yield strength to ultimate tensile strength. For example, a property class 5.8 bolt has a nominal ultimate tensile strength of 500 megapascals, and a tensile yield strength of 0.8 times ultimate tensile strength, or 0.8 equals 400 megapascals. Ultimate tensile strength is the stress at which the bolt fails. Tensile yield strength is the stress at which the bolt will receive a permanent set of 0.2% offset strain. When elongating a fastener prior to reaching the yield point, the fastener is said to be operating in the elastic region, whereas elongation beyond the yield point is referred to as operating in the plastic region. Since the fastener has suffered permanent plastic deformation, mild steel bolts have property class 4.6. High-strength steel bolts have property class 8.8 or above. The same type of screw or bolt can be made in many different grades of material. For critical high tensile strength applications, low-grade bolts may fail, resulting in damage or injury. On SAE standard bolts, a distinctive pattern of marking is impressed on the head to allow inspection and validation of the strength of the bolt. However, low-cost counterfeit fasteners may be found with actual strength far less than indicated by the markings. Such inferior fasteners are a danger to life and property when used in aircraft, automobiles, heavy trucks, and similar critical applications. Inch SAE J429 defines the bolt grades for inch system-sized bolts and screws. It defines them by grade, which ranges from 0 to 8, with 8 being the strongest. Higher grades do not exist within the specification. SAE grades 5 and 8 are the most common. Metric. The international standard for metric screws is defined by ISO 898, specifically ISO 898-1.